So you first of all would have to add 140, 150, and 130, which will equal 420. Then you subtract 720 by 420, and you will get x equals 300.
Nice, good. So what can you do?
Subtract it by 180.
Good, 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 good.
300.
We need to work on the idea that being good at math is not a matter of getting it and doing it fast.
Now, can I get Madison to say what you do when you plug in the vertex?
You plug the vertex.
So it's not about how fast do I arrive at this as much as what is it that I need to know, what I need to understand, and what I don't know yet. So once I have that as the culture of how I learn in class, then I think it allows us to build something more. It builds the understanding.
What are you thinking that you have to do?
Cosine, I can do tangent, I can do hypotenuse, because there's no missing sides. There's
That's
all
good.
sides are found.
So then it's up to you which function you want to use.
All kids can do this. It's how do we present the opportunities for them to engage in it. And here's the thing. How do we persevere in being persistent in this?
As Carol Dweck has talked about in her research, it's not something that some people have and other people don't. It's something that you can learn. It's something that you can practice and get better at.
We want to be able to share that the brain is malleable, that it is not fixed, that it will grow and it'll stretch in a sense. But that has to be taught. That has to be made explicit to students. When I persevere, I am growing. When I struggle, I am getting smarter. And those messages from the teacher are vital in order for kids to buy in.
If teachers want students to be successful with problem solving and to persevere in solving problems, then I think a good idea for teachers is to model that problem solving process, to illustrate how they work through a problem, to also show some of the challenges or struggles that they have as they encounter a problem, and even to model what they are going to do if they become stuck.
I think that teaching perseverance and problem solving has an equity message. Typically, children who have not been well served in our schools are judged to be unable to solve problems in mathematics. And so their curriculum consists of formulas, arithmetic, memorizing, and not really problem solving.
What are you thinking about right now?
A sine, right?
So then which angle would you need to focus on though?
So you'll write 249.
Oftentimes, perseverance is referred to as try harder or do it again. But those are not very helpful. So perseverance is really the way in which we want kids to enter into problems with a toolkit in mind.
All right, I'll let you guys keep working with whatever strategies you have.
Let me try.
Okay, you plug in one.
-3.
So there has to be explicit teaching and understanding around how is it that I should approach a problem? What do I bring to bear when I look at something strange and unfamiliar? And how do I use my toolkit to enter the problem? So the perseverance comes from knowing that I have a viable pathway and to use the skills I have in that viable pathway to enter the problem.
What are you trying here?
This one, I just checked it out. So I did this problem with these variables. So B and D are out because I did both of those and they didn't line up. All right, and we know that this one is C. Couldn't C be out too? Yeah. So this would be A.
Teachers want students to persevere in the classroom, then teachers have to listen to their students and then ask questions based on students' responses, students' comments, and students' questions.
Anybody else have something they would have done differently if they do it again next time, Alva?
It was really hard to get the measurement of the staircase, so I feel like next time I should have just gotten the length and the distance and just find the missing side. I think that would have been easier.
Nice. Let the math work for you instead of you working. I like that.
Leave the thinking to the student. When you tell them things, make sure what you tell them doesn't do the thinking for them. ask students questions that will get students to reevaluate their thinking.
Part of perseverance is that students will continue to work if what they are producing is valued and there's growth from that. So it's not about I'm being rewarded because I'm right. I'm being rewarded because I've contributed something to the culture of the room, and we're all learning from that.
We want the number of observations. There's 4 observations, so let me take out let me write that down.
Do we have to square all of those? All of them?
Yeah, you see, if you look at our previous notes, it's right here where like we would square them by the number of successes we want.
One thing I would look for is whether they can identify where they're stuck and what they're stuck about. Then that translates into a student being willing to productively ask for help.
Students' ability to persevere is intricately linked to their metacognitive abilities. And even in this, teachers have to teach students how to reflect and what to reflect around.
What things did you do with your partner that helped you be successful in this activity?
Those habits of mine take cultivating. It has to be given credence in the classroom as this is what we do to learn. We step back, we think about what we've done, we celebrate the great things, and we also make notes of things we're not ever going to do again.
What do you need to know to start that process?
The hypotenuse.
What else?
The kids' experience in mathematics is changing in a positive way. Their stick-to-itness is longer. Their willingness to try even when tangential pathways are frustrating. They're willing to come back and say, oh, I'll try this one instead. When kids are willing to explore, you know that they're persevering. And that's giving opportunities for them.